Hey guys, welcome back here to section 3.3, video 3. We are on example number 5. We're talking about properties of logarithms. We've got 3 properties of logarithms that you did not see last year in Algebra 2. And these are the product property, the quotient property, and the power property. Product property just means like multiplication property. If I've got a log that has an argument that's multiplied together, that's where we get the product part of this. If they're multiplied together here, I can split this log into 2 logs where I add them together. If my argument has got a division, a fraction in there, I can split that up as 2 logs where we are subtracting in there. And then the power property says if you've got a log of an argument raised to a power, you can bring that power and multiply it times the log itself. So you can bring that p, the exponent, down and put it right in front there. All right, so looking at A, it says to express this logarithm in terms of log 2 and log 3. So I want to break this guy down. And so natural log of 54, well, that would be natural log of 9 times 6. So this is a multiplication property. So I'm going to go up here to my product property, which says I can split that into 2 different logs with an addition sign in between it. So this is natural log of 9 plus the natural log of 6. All right, likewise, 9 is 3 times 3. So this is the natural log of 3 plus the natural log of 3. And 6 is 3 times 6. So this is natural log of 3 plus the natural log of 2. And that would be expressed in terms of natural log of 2 and 3, except that I would like to make it a little bit nicer. I've got 1, 2, 3 natural log of 3, so if I add those together, that's 3 natural log 3 plus natural log 2. All right, looking at B, this time my argument is being divided, so I'm going to use the quotient property, which means when I split it, instead of having an addition sign here between them, I'm going to have a subtraction sign. I'm trying to get into base 2s and 3s, so I know 9 is 3 squared and 8 is 2 cubed. And then I'm going to use the power property to move these exponents down in front. So this would be 2 natural log 3 minus 3 natural log 2. Whoops, not 3 in this error, it's 2. All right, for our U-tries, this time we're trying to break it down into 5s and 3s. Well, I know 75 is 3/4, so that'd be 3 times 25. And since it's multiplied, I'm going to break it down to 2 logs where I'm adding in between. And then 25 is 5 times 5. So I can break that down into 2 logs, 5 and 5. And I can add those guys together since they're the same log and make that 2 log 5. For B, it's log of 5.4. Well, that would be the same thing as 54 divided by 10, which reduces down actually to 27 divided by 2 goes into 10 5 times. And so that's log 27 minus log 5, because it's division here, we're going to subtract. And 27 would be log of 3 cubed. It would be 27 minus log 5. Last step would be moving that 3 down in front. So 3 log 3 minus log 5. Moving on to example number 6. If I've got a log base 4, I'm going to try to write this argument into a base of 4 as well. If I can make this guy into a base of 4, then it's just going to be equal to the exponent. So first I'm going to say this is actually 64 to the 1/5 power. Because remember, the nth root, so the nth root of a number is going to be an exponent form, x to the 1 over n power. So since this is the 5th root, it's 64 to the 1/5 power. But I need to get it into base 4. Well, 64 is 4 cubed. And now when I raise an exponent to another exponent, I multiply those exponents. So this is log 4 of 4 to the 3 times 1/5, which is 3/5 power. Now these bases match, so this is just equal to 3/5. For b, I've got 5 times the natural log of e squared. Here my bases match, right? This is log base e of e squared, so this is just really 5 times 2. Minus log of e cubed is 3. 10 minus 3 would be 7. All right, same ideas for these U tries. I want to get this into a base 6. So first I'm going to get rid of that cube root, make this 36 to the 1/3 power. And then 36 is 6 squared. So my exponent here is 2 times 1/3, which is 2/3, and so that is my answer, since the bases match. Natural log of e to the 9th is 9, plus 4 times natural log of e to the 3 is 3. 9 plus 4 times 3 is 12, would be 21. All right, and then I'll get examples 7 and 8 and 9 on the next video.